Welcome to one of our first workshops in MuniHac. I'm pleased to introduce Andres Lö. Andres has been programming Haskell for a long time, and he's also working in Haskell commercially. He works at Well-Typed, a Haskell consulting company, and today he's gonna teach us about Liquid Haskell.
Thank you very much for the introduction. Yes, so exactly. The idea is that in the next roughly 3 hours, we're going to look a little bit at Liquid Haskell. And this is all going to be sort of code that we're developing interactively. And I'm going to hopefully get some help from you in places. And you can, of course, ask questions at any time. Tim will monitor the Slack channel, and I will try to a little bit as well. And yeah, I mean, just ask questions when they come up, and I'll try to answer them. So what is Liquid Haskell? It is a tool that extends or strengthens Haskell's already rather powerful type system yet further. But perhaps in a slightly unusual direction. It extends Haskell with so-called refinement types. And as a way of checking these refinement types, it is not implementing a type checker on its own, but it is using an external automated theorem prover, preferably Z3, which is why you, if you have been following the preparation instructions, had to install that in order to get things running. And I should perhaps start with saying a little bit about how Liquid Haskell works conceptually, because that explains some of the peculiarities that we have to deal with today. So, so if you consider GHC, the compiler, the pipeline that GHC usually employs, then GHC starts roughly by parsing a program, a Haskell module, and then the Haskell module is renamed, it's called. There's sort of scope analysis being done, and then type checking happens, and then desugaring happens into some intermediate language that's called core, and then a lot of optimizations happen on core, and then ultimately the backend is running and some out code is being generated, right? And conceptually, as a first approximation, the way you can view Liquid Haskell is as inserting an extra phase after GHC's type checking phase. So there are two type checkers being run. So the first being Haskell's type checker, which is still running as normal and is not more powerful as before. It sees just what the Haskell language offers you, essentially, or the Haskell language as interpreted by GHC. And afterwards, an additional type checking phase is running, which is Liquid Haskell's type checking phase with extended information. And that type checking phase can also fail, right? Just as the first Haskell type checking phase can produce a type error, Liquid Haskell can also produce a type error. So ultimately, Liquid Haskell will say one of two things. It will say your program is safe, which of course doesn't really mean that it is error-free, but it means that as far as Liquid Haskell is concerned, it is okay with it, and compilation will continue. Or Liquid Haskell will say unsafe, and it will give you an error message that is more or less good. In many cases, it's also less good. So that is, as a slightly simplified approximation, the right viewpoint. And the next thing I should probably say up front is that historically, Liquid Haskell has been a separate binary that you would run on a Haskell program in addition to GHC. So what I just described as this pipeline viewpoint does not really apply, although it's still very similar, but you would essentially run Liquid Haskell before running GHC. Liquid Haskell, the binary, would already perform part of GHC's work by interfacing with the GHC API and would either say yes or no to your program. And then if Liquid Haskell says yes to your program, you would then go on and call GHC. And relatively recently, at well-typed, Alfredo Di Napoli and I, together with Ranjit Jala and Niki Vasu, who are the two main Liquid Haskell developers these days, have been modifying Liquid Haskell so that it is now a GHC plugin, so that it now is closer to the viewpoint that I've originally described, that it really just is an additional type checking phase. And you don't really have to run a separate binary or anything, and you can just basically insert it into your compiler pipeline and use it naturally. Nevertheless, there are, as I said, there are restrictions to Liquid Haskell that are coming from its history. And primarily that is that there is not a very tight integration between what Liquid Haskell is doing and the rest of Haskell. In particular, Liquid Haskell does not change or modify your Haskell program in any way. There are no results of Liquid Haskell's additional checking that go beyond saying yes or no to your program, no with an error message and yes with perhaps some information attached to it as well. There is no evidence of a successful type checking produced beyond that. And in some places, that means that things are less convenient than they could be, but perhaps the step of changing it into a plugin is a first step on a road where Liquid Haskell could become more tightly and more seamlessly integrated into the Haskell language. So perhaps that's enough as sort of an advanced start.
Sorry to interrupt.
Yeah.
There's one thing that I forgot to say. We are streaming this workshop live on YouTube. And if you don't want to see yourself on YouTube or hear yourself, then you have to mute yourself or stop your camera. And if you're watching this from YouTube, please notice that we also have streaming this from Zoom, and that there's a Slack channel which is linked from the video description. So if you want to ask questions, please join us there. So that's it.
Okay. So as far as the code that we're going to develop today is concerned, everything is in this GitHub repository. At the moment, there's very little there, but hopefully by the end of the tutorial, there will be more. And you can, but you don't have to clone this and try to build this. I will actually start, because it's a good continuation of this sort of architectural viewpoint that I've just explained, by telling you how you can set up a project in Haskell now so that you can work and play with Liquid Haskell. So this project that is contained in this GitHub repository is already such a project. But let's actually start by having a look at the Cabal file and point out the important aspects. So most of this is completely standard, but there is one important point here, that is this GHC options part, where I'm saying, in this case, for the entire package, that I want to use the Liquid Haskell plugin, right? That then applies to every source file within the package. You could also enable it just for a couple of modules within your package. And because we're depending on the plugin, we also have to depend on Liquid Haskell, the package, which provides the plugin, among other things, and provides all the basic infrastructure of Liquid Haskell. And the other thing that is unusual is that we are not depending on base, but we are depending on Liquid base. And Liquid base is set up in such a way that it essentially exports exactly the same things as base under exactly the same module names. So you can work with all sorts of Haskell libraries just as you're used to. But in addition, some of these base library entities have already been annotated with a stronger Liquid Haskell related types, and also some basic setup that is needed for Liquid Haskell to work at all is being provided. So if you want to use the plugin in a Haskell package, you have to like flip your dependency on base with a dependency on liquid base. And ideally, the version number should be set up in such a way that they are identical to the corresponding base version number. So it should really just be the matter of replacing the dependency on base with the dependency on liquid base. And then later in this tutorial, we're probably also going to use some functions from containers, and some other libraries also have sort of additional Liquid Haskell specifications attached to it. So there are a few more of these wrapper packages, but not very many. And these are also more optional, because you really only need to use those if you want to use some of the specifications, whereas liquid base is essentially required for things to work correctly. These are the only real things that you have to set up, and then you can start using Liquid Haskell. Liquid Haskell, as I said, is not very tightly integrated. So everything that is actually Liquid Haskell specific is surrounded in specific markers that look like this, like curly brace, dash, and an @ so that they look like comments as far as Haskell is concerned. But then there is a special syntax available inside of them that is Liquid Haskell specific. So this everything that is on line 11 here in my editor, that is a Liquid Haskell declaration, and the rest is a normal Haskell program. And if I would omit this, then everything would just normally compile. And if I add this, then the plugin runs. And the good thing of having this as a plugin is that basically for free you get integration with all sorts of development environments. So if I just call Cabal REPL, for example, and just use GHCI and nothing else, I will see that my tutorial module compiles, but I get this additional message from the plugin that in this case says that Liquid Haskell is okay with what I wrote. And it also gives us a number that is just a general indication that we can check that it's been doing some work. So if this number is 0, then there are some cases in which 0 is the right answer. But if the number is 0, even though you wrote, or think you wrote a lot of stuff that should have been checked, then that is a possibility to be suspicious. And also, if you, for example, use GHCID, so that is this daemon which runs GHCI, the plugin will still run. And if I now make a mistake, then ideally I will get both an error message from GHCID, which is running in here, and in this case from my editor where I'm running GHCIDE, which also basically has automatic support. But the point is by having this as a plugin, it's not necessarily the case that everything will always work right, because like editor integration with GHC plugins, there is still a little bit of an unknown territory. There are not that many plugins that work like this one, and so it's not guaranteed that it will work, but there is a large chance that things will just work, right? And that is one of the nice aspects of it. Okay, so this program that I've written here with this example type, that is already a good demonstration of what refinement types can do, but let's perhaps start a little bit simpler than that. And let's look at a very first example, which is just an integer. And I say, like, I choose an integer, let's say 3. Now, I can optionally give a Liquid Haskell type signature for this as well, in addition to the Haskell type signature. And the simplest Liquid Haskell type signature that I could be giving is to just, what happened now?
Hi, could you increase the font size maybe, please?
Is it too small? Okay, yeah, good. Is this large enough? Better?
Yeah, better. I mean, sure.
Yeah. Okay, sure. So the simplest Liquid Haskell type signature I could be giving is just the same. I'll remove the comments because they are no longer relevant, and I'll also remove the /gHCID down here. Now I can start being more precise. So this is a basic type. And if I want to refine it, then the syntax for that in Liquid Haskell is to use something that looks like a set comprehension notation. So we can write curly braces. We can give a name to the integer, right, of our choosing, then use a single colon, then write a bar. And then here I can write some predicate that I want for the integers to hold. And I can be completely trivial. I can say the predicate I'm going to write down here is true. That should always hold. Then, I mean, this is still the same type as just int. But I can now also say certain things. So I can say that I want this int to be less than 100. Right? And that is OK in this case. But should I go and change my integer to 102, I would now have a type error. OK. And it would actually say Liquid Haskell type error messages are not always easy to read, but in simple cases like this, it is quite possible. It would say there is a liquid type mismatch. It says the inferred type is that this is an int that is equal to 102. And the required type this is an int that is less than 100. And it says that the inferred type is not a subtype of the required type. And indeed, there is implicit subtyping, which is unusual from a Haskell world, right? I mean, there are all sorts of things that are subtypes of one another. So in particular, if I have an int that is less than 100, it is still an int. I can use it everywhere where an int is expected, right? But not the other way around. And I can make stronger conditions. I mean, I can also say that my integer, I mean, I can say that the integer is less than 105, and then this will work again. But I can also say that the integer is supposed to be greater than 50 or 60. And then I can put an and here, and then it must be in this range. And then 102 is OK, but 40 is not, right? And but 61 is, and so on and so forth. I can also put or here. I can put other conditions here. But there is a limited language. This is something I should say up front, right? This is not full Haskell, even though the syntax looks similar to Haskell. This is not full Haskell. There is a limited language, which is somewhat extensible. We'll see that. So you can add new things to this language yourself so that you can express more interesting things. But this is sort of a limited logic language. And for the beginning, you can assume you have at least the option to refer to these variables that you introduced in the type signature itself. You have integers, you have like arithmetic operations on integers like plus and times, you have comparison operators, and you have logical operators like negation and or and implies and if and only if and these sorts of things. That's sort of the basic language you can assume that you have. Okay, so let's now perhaps already take a look at this other example that we've had here, which is like significantly stronger. So here we are calling replicate. Replicate, let me perhaps start also the REPL. Replicate is a function that takes two integers, right? And the first integer says how many copies you want, or actually it doesn't necessarily take two integers. So the first is an integer, the second is an arbitrary thing. It creates 5 copies in this case of the element 2 in a list. Right? And the type that I've given here is actually very, very precise. Right? It says that if you look at it, I should perhaps not have used X as many times. So perhaps let's call this one I. Oops. All right, if you look at this part here, this is actually a list of integers, but I have refined the integer type to say that the integers that occur in this list are actually all equal to 2. Okay, so this is a list of 2's. That is what the type says. And then furthermore, I've given a name to the list, and I have said that the length of the list is 5. And len is a way to refer in this predicate language to the length of a list. Again, I said it's not exactly Haskell. Len is a special thing that is provided to you by Liquid Haskell to refer to the length of a list. I don't know exactly why they haven't called it length. That is not that's not been my decision. I think it would have been nicer, but right. Okay, so I'm seeing a question. I tried removing 2 from replicate 5 2. You mean just the argument, like this? Okay, let's see what the error message is. Invert type. Int is not a subtype of the required type. That is indeed a strange error message. Is that the same error message we're getting? Oh no, I haven't saved. The same error message we're getting here, just to check. No, interestingly not. Okay, so this is perhaps a glitch of the. Perhaps there are glitches of the IDE support that sometimes the sort of the Liquid Haskell error message hides a Haskell error message when it shouldn't. So that almost looks like this. Okay, so we found our first bug in a way. So I think this is probably not Liquid Haskell itself to blame, but us to blame for implementing the IDE support incorrectly or not debugging it correctly. So yeah, good point. There is another question that says, how do you refer to local definitions in the Liquid Haskell type if you can? I think this is getting too far too soon, but please ask this again at a slightly later point when I've explained more of the basics and I haven't got around to it yet. So I think we have to look at a few more of the basic things first to make sure that everybody is able to follow along. So basically this type signature, to summarize, is very precise, right? We're saying we have a list of exactly 2's and we have a length of exactly 5. And if I change anything here in the arguments, if I change this to 3, then it becomes type incorrect because now I have a list of 3's rather than a list of 2's. And also if I change the argument here, now I have a list of the wrong length. And now we can see that the error message is getting harder to read, but it is still making sense. I mean, it's essentially saying that this type in here is the one that is expected, a list of 2's, but then it knows that the length is 6, and it redundantly knows that the length is greater than or equal to 0. So it's not always like showing sort of the optimal amount of information, but it wants to know that the length is equal to 5, and it cannot infer that from what it has. So this is a very precise type signature, but of course we are not required to give such a precise type signature. And indeed it is like, I mean, even more than perhaps with normal Haskell, it is the case with refinement types that we have a wide range of how precise we want to be, from essentially just repeating the Haskell type to adding in a few extra checks to doing more and more, and to all the way to, in some cases at least, to more or less precisely describing exactly what is happening and leaving basically no room for deviation whatsoever anymore.
Yeah, this is probably related to a question that was asked in the Zoom chat window. Is there any kind of controversy about the choice of these Liquid Haskell signatures? If so, could that lead to some people deciding that they aren't happy with Liquid base and writing their own package?
Yes, absolutely. I think that's a very good point, and we'll probably see a couple of these examples. That is something where I personally believe it's just a lot more experience is needed. But I mean, in terms of like what are the good type signatures and what are the bad type signatures. But of course, to some extent, one can say that if one tries to be very precise, then one can still make the type weaker again, right? I mean, like certainly, like establishing knowledge, like here, this is a result, like this is a list of integers. That is, if we make this so precise, we're not really losing very much, right? At this point. But it becomes more interesting when we look at functions, because then we are getting into the situation where we have preconditions and we have postconditions. And sometimes there is a choice whether you want to be very strict in your preconditions, right? Whether you want to have very strong expectations of your input, or whether you want to be liberal in your input, and then you can perhaps say a little bit less about your output. And then it's not always clear that you can turn one thing into the other. And then indeed you might want multiple variants of the same function with different types. But I mean, that is a good problem to have, I think. I mean, like if people start saying, well, we all want to use Liquid Haskell, but we are not happy with the type signature of a particular function in base, then that's a good sign. I mean, that means that people are using it and that people care, and it's good to think about this. And there are perhaps still like design issues that can be improved there. Certainly, I mean, nobody is claiming, I think, that things like Liquid base or so are complete right now, right? And there's a lot of work to be done there. In fact, also more of an excursion again, one of the main reasons why we did this plugin work was also that it now is much easier to like to write your own libraries and to add specifications to existing stuff. And before that, most developments were not really using a lot of stuff. So if you wanted to change something or you were unhappy with one of the basic specifications, you would just go and change it, right? Because it's more or less an isolated development anyway. But now with the package system of Haskell that we can reuse through the plugin, there is perhaps potential for more controversy. But again, I think that's actually a good thing, because then that means that people actually talk about this, and then people will like identify the problems, and then also progress can be made as to what the best options are. Okay. So let's look at some other examples, and in particular, let's look at some functions themselves. So let's see, for example, tail is an interesting function, right? And let me tail from the prelude, and let's look at tail as it is normally, as you would write it. So that takes a non-empty list and it returns the tail. And we don't really need the X, so I can put an underscore here. And one thing you can notice that if I type this into Liquid Haskell, then I already get a type error, and I get a very, very strange type error again. And this is another thing that I don't agree with, but actually, I mean, this is just a strange hack that if you have an incomplete pattern match, you get a very strange type error. I don't know exactly why that is. There is some sort of like technical reason why this is the error you're getting, but essentially it is just a hand-coded strange error that rather than a meaningful incomplete pattern match error that should be changed. But for the time being, while this is the case, if you see something mentioning adder sharp or adder hash with 5 less than or equal 4, that is always an incomplete pattern match error. That means that you haven't done an exhaustive pattern matching. And in fact, Liquid Haskell by default is total. So if you're not doing anything special, you'll have to prove to Liquid Haskell that the functions you're writing are terminating and that they're exhaustive, that they don't crash. And there are some ways around this. So I mean, an easy way to shut up Liquid Haskell is to say lazy tail. Actually, why does that not work? Oh, it doesn't work. Okay, I'll give up on this. I don't know. I want to fix this anyway. So normally you can, I mean, totality checker and termination checker are slightly different things. So the termination checker you can turn off for a particular function with lazy, but perhaps the exhaustiveness checker not. But what we really want to say is that the list that we are expecting here should not actually be empty, right? So we can do this. So we can write we want as an input. Oh, now I'm making the typical mistake, which is all too tempting, and editing the Haskell type signature, but I have to write an extra copy of the type signature. So I can say I want an input list XS where the length of XS should be greater than 0, right? Strictly positive. And then for the time being, I get another list back. Okay. And now Liquid Haskell does no longer complain. But if I would enable all warnings, then Haskell would still complain. So I could actually still want to write a catch-all case, or even a case for the empty list where I'm saying something like error impossible tail on empty list. Okay. And now, interestingly, Liquid Haskell is checking this as well. So error has a type which expects a string as an input, but the predicate on the string is false. So look at the type that error has. It has exactly the same type as this impossible function that I'm writing right now. And the type of impossible is that it takes a string with the predicate false to some type A. What this means, this is sort of like I said, if you write true here, then it doesn't have any constraint whatsoever. If you write false here, then Liquid Haskell will complain unless it can prove that this cannot actually be called anyway, right? Unless it can prove that this is actually in an impossible situation. So if I call impossible in any other situation, if I just write impossible foo here, I'll get a complaint that this is not the right type because I have a string, but I have a string, I expect it as a string with the predicate false, right? So, so this call is not legal. And the reason it is okay here is exactly because Liquid Haskell can prove from the precondition that we are expecting a list that has a length greater than 0, that this error call cannot actually occur, right? So that in this situation, we are already in an impossible case. And then that is fine. And then this is a good way of writing code that is both checked by Liquid Haskell, right, for something actually being unreachable. So I could use impossible here now as well. That is just the same. And also Haskell will not complain about non-exhaustive patterns, even from its viewpoint, because again, of course, ultimately you might want to have some integration between Haskell's exhaustiveness checker and Liquid Haskell's type system, but at the moment they are very separate. And also to some extent that will probably always be the case, because Liquid Haskell will always be an add-on, and one could imagine that, for example, this duplication of the type signatures is something that should be easier to change, right? Because in a way, the Liquid Haskell type signature contains all information that is also in the Haskell type signature. So the plugin could go and extract a Haskell type signature from the Liquid Haskell type signature and give that to Haskell to work with. So that is an extension or a future development of Liquid Haskell that is plausible. But this integration with the pattern match checker is probably further off. Okay, so let's look at how we can use tail. So let's again look at an example. So if I now call tail on the empty list, it is giving me a type error because I'm expecting a non-empty list. And if I call tail on 1, 2, 3, this is going to be okay. That's fine, right? Now a question for you is what happens if I call tail on this again? So if I write, I have to be really careful now that my IDE is not giving it away. If I write tail of this again, what happens? Is that type correct or is that not type correct? What does my audience think? Right, I see in the Slack chat that someone says it fails because tail doesn't have a post condition, and indeed that is what happens. So if we call tail on this list, which we expect to be greater than 0, we get still a list of A's back, right? And we don't know anything more about this resulting list than that it is a list. So even though here we can see in this concrete case, there will be a non-empty list arising, it is still a static check that we're performing. It is still a check based on the information that is declared in the type signatures. And the type signature of tail says it expects a list that is of length greater than 0, and it gives back any list, right, of which we don't know anything more. So if we wanted to make this call work, then what post condition should we add? To the type of tail. Yeah. Multiple answers by multiple people, and they're all correct. That's good. Very nice to see. So probably too slow. We should say this is a list, and we have to give it a name as well so that we can refer to it. And then we can relate the length of this resulting list to the length of the input list. And in fact, we can say that the length of the resulting list is the length of the input list minus 1. And then it works, because now if we start with a list of length 3 and we take the tail of it, we'll actually know at this point after this call that is a list of length 2, right? And so this is fine, and we can call tail again, and it will still be fine. And then we can call tail again, and then it will no longer be okay, right? Because now we have applied 4 times tail to a list of initially only 3 elements. And of course, we wouldn't need to know here that this is a list of exactly 3 elements. We could like turn this into a function again that applies something to a list and gets a list out. But then of course we have to make a stronger precondition, and we have to say that the input list has to have a length of now at least 4, right? I mean, if we require something more, if we say it's a length of 10, then it's going to be okay, right? I still have to add a result type, right? But at the very least, I should say that the length is 4. right? And if I require less than 4, it's going to fail. This is going to be a type error again. But if I require at least 4, this is fine. And again, of course, I can also say that the result type should perhaps also be annotated so that the result of this list is the length of the input list minus 4. This is also going to be okay. But again, I don't need to be as precise. I mean, I can also, for example, just say that I want to establish that the length of the resulting list is strictly smaller than the length of the input list, and that's still going to be fine. But then I know less, right? So this is the sort of the trade-offs that we're working with.
Yeah, sorry to interrupt. There are several questions in the Slack. Sure. The first one is whether you could use something like existential quantification to formulate the tail condition, the post condition of tail. There's a proposal in the Slack.
I think the short answer is no. There is, as I said, I mean, there is a limited logical language available, and in essence, it is a first order language. So anything that involves quantification is going to be very difficult. So one could, of course, think about adding these kinds of things, but I don't think they're currently possible. And also it's going to be, like, in implementation-wise, it's going to be relatively difficult to encode such things in Z3. So one of the things that play a role in designing Liquid Haskell is that Z3 as a system itself is not necessarily complete, right? So there are problems that you can pose to Z3 where Z3 says this is okay. So what you're saying is correct. There are problems that you can pose to Z3 where Z3 says this is not okay. And there are problems you can pose to Z3 where Z3 says I don't know, right? But Liquid Haskell takes care to be sort of in the decidable subset of Z3 and to only pose problems where the answer is either clearly yes or clearly no, and not to leave you hanging with maybes. And so in some places, that means that the language is less powerful than you could possibly imagine. Okay.
Another question: could GHC extract the post condition automatically in simple cases?
I guess yes. I mean, I guess in principle, yes. I mean, in practice, it would be relatively tricky to do, again, because of the still relatively clear separation between GHC and Liquid Haskell. But in theory, I think it should be possible in some cases. But I would be a little bit reluctant. I mean, perhaps as a sort of tool for interactive development, right? I mean, there it could be nice if you could just basically tell your editor, oh, please try to derive a post condition for me here automatically. But if it implicitly did it everywhere, I would feel like it's too fragile, because I want to have some reliable types to work with, right? I want to have a declaration in my type signature where I know this is actually what I'm establishing here. And sometimes I might want to deliberately forget certain things rather than carrying absolutely everything around. So yeah, so giving this as an option that sometimes can be invoked, I think that would be nice functionality. Probably not easy, but theoretically doable. Having this as a feature that is automatically available on always active, certainly not, I think.
Yes, one more question. The import in line 3, does it refer to base or liquid base?
We are not even depending on base now, right? So the package is depending on liquid base. Liquid base exports exactly the same modules as base exports, so that really the switch from base to liquid base is one that you can typically just do in your Cabal file. And then all your module names will be referring to liquid base instead, all your base module names. So this is referring to the liquid base prelude. But as far as Haskell is concerned, they're identical, right? So the Haskell part of it is the same. Only there are additional Liquid Haskell things available.
One more question which just came in. If I call a function which has no Liquid Haskell annotation from an annotated function, does Liquid Haskell infer an annotation for it, or must the whole call tree be annotated?
That's a very good question. And this is already, like, I should make a disclaimer here that I'm not myself a Liquid Haskell developer, right? So I mean, well, I mean, I've been working to Liquid Haskell to some extent, but I'm not like very, very deep in the details. So there are a lot of places where my knowledge is perhaps a little bit vague. But to the best of what I currently know, for top-level definitions, you indeed have to give explicit Liquid Haskell types. So let's look at a variant of our example where we have tail 1, 2, 3, right? And let's now make a list 1, 2, 3, and let's write list here. And now it starts going wrong. So because this is a top-level definition, and if I want this to be actually a list of length 3, right? Then I have to give it a Liquid Haskell type annotation where I'm saying list is actually a list of integers where the length of access is 3. However, if I turn this into a local definition, then it'll still work. So so I think this is a compromise which is okay, because I mean, generally, I think the idea is anyway, like for top-level definitions, you want to have type signatures anyway, right? And if you have a type signature, you probably want that type signature to be like the relevant type signature, and not for Liquid Haskell to sort of infer something around it. But it is it's sort of a strange case. It's a very good question. Thank you for asking it. In general, yeah, for top-level definitions, you have to like make an explicit choice as to what you want to keep around. But if you're within the function, then Liquid Haskell will infer types for the components. And this is as far as IDE support goes, as all sort of the automatic or out-of-the-box IDE support goes, is still something where the new plugin is also weaker than it could be, than you might want to, because like for example, GHC IDE gives you this option of like showing the Haskell type of something like this list prime, and it will tell you that this is a list of integers. And it would be really nice if we could also show the Liquid Haskell type that Liquid Haskell has inferred. And in principle, Liquid Haskell does produce it and can write it to a JSON file or something like that. And then we could read it in from the IDE and display it in the right positions. And the older Haskell IDE engine had a specific plugin for Liquid Haskell based on the old executable that could actually do this. And I think tomorrow, Pepe Iborra is going to give a workshop on writing plugins for the new Haskell language server, which is built on top of GHC IDE. And I want to basically port this old plugin for Haskell language server, for Haskell IDE engine over to Haskell language server. So then this would be a bit yet easier to work with. That would be quite nice. Okay, that's good that there are so many questions. let's perhaps look at one more list function as an example. So let's take something like, yeah, let's take, because that's a good example of where things perhaps start becoming controversial, because that was one of the questions before. All right. So take, as far as like Haskell is concerned, is written roughly like this. So you have an int and you have a list of A's and you get a list of A's, and you have an I and you have an access, and then you have multiple things to check. And you can choose a little bit as to what the order is. But so one thing you can do is you can check whether I is less than or equal to 0. And if I is less than or equal to 0, you're always going to return the empty list. And then if that is not the case, then you can check whether access is the empty list. And if that is the case, you'll also going to return the empty list. And then if you're in this case, you know that I is greater than 0 and you have more than one element in your list, or at least one element in your list. And then you can return that element, and then you can take I minus 1 out of access. Okay. And now I'm getting, this is a Haskell error that this is ambiguous, so I'm going to hide take from the prelude as well. And this is okay, right? This function is okay as far as Liquid Haskell is concerned. It is not like it has exhaustive patterns and so on and so forth. But of course, we could try to give it a better type, right? Somehow. And now there are actually multiple options for what kind of better type we want to give it. I think there is one modification to the type signature which is relatively uncontroversial. And then perhaps the controversy starts. But do you have any suggestions for what kind of refinement I could be doing? The length of the input should be equal to the length of the output plus I. That is, yeah, I mean, and I suppose is the integer. I should be equal, less than or equal than the length of the input. That is similar or strictly less than. Okay, that's also. I mean, I thought we could perhaps first start by saying something about the integer, just in isolation, before we go into this complicated relationship between the length of the input and the length of the output. Right. As Gabo says, I mean, so it's reasonable, I think, to require that the integer should be greater than or equal to 0, because it's really morally a natural number, right? We want to take something out of a list, and I mean, calling this with a negative number is sort of set to the empty list a little bit out of desperation, I think, in the Haskell prelude, because, well, we don't have a natural number type, and crashing is a little bit unsatisfactory as well. But I don't think there are in practice very many good situations where this is actually useful. So, so one option we certainly have is to require that that take is like that the integer is greater than or equal to 0. And in fact, this is such a common case that, like, restricting integers to essentially natural numbers, where natural numbers here start from 0, that there is a type synonym defined for this in the Liquid Haskell prelude, essentially, which is called nat. And you can define such a type synonym yourself I'm going to call it nat prime now, because nat is already defined, so just so that it doesn't clash. And the idea is that you can, this is a Liquid Haskell type synonym. So you're writing type, but within a Liquid Haskell comment. And then on the right-hand side, you can write a refinement type, okay? And so we can say this nat is supposed to be something for an integer which is greater than or equal to 0. Okay, and once you've defined this type synonym, you can use nat prime instead of this more complicated refinement type. And it works just as a Haskell type synonym, but it's only possible to use in Liquid Haskell types. And then we could write that take should take a natural number to a list of a's to a list of a's. And that still works. And in fact, it works without the prime, because this one is available to you already in essentially from the prelude, right? I mean, this is part of liquid base. And if you import the prelude, you already have this type synonym, because it is very, very nice to have. So so that is, I think, an uncontroversial change. And then indeed we had I think two other qualitatively two other options, right, that have been suggested in the comments. One was to say that we are saying that the output list really has as many elements as this natural number indicates, right? So we say something like the resulting list is something where the length of the resulting list is equal to n. But of course, if we want to guarantee this, right, then our code is currently not going to type check. Then we also have to assume quite a bit about the input list, right? And we in particular have to also assume that the length of the input list is at least length n, because if it is already shorter, we cannot suddenly produce additional elements, right? So then we have to say this is at least n. And that is one possible type signature that we can give for take, right? And that works. And then we are relatively restrictive. Then we are saying that you cannot take more elements out of a list than there are there, and you always have to prove whenever you call take that your list is actually long enough. And that may be good in cases where you can prove it, but there may be other cases where you cannot easily prove it, and then it's a little bit annoying that your code is going to be rejected by Liquid Haskell. So there is also an option of retaining this idea that like if you want to take 10 elements out of a 5-element list, you're only getting the first 5, right? So retaining that behavior and still saying something, and that has also been suggested, I think, by Tim and possibly by others as well. And that is to say that the length of the output list is the minimum of the n and the length of the input list. Okay, so let's see if we can write this as well. And this is a little bit more complicated because we need minimum, and minimum goes slightly beyond what we have available by default. So, but we can still easily do it. I see more questions coming up, but I'll first complete this type signature, and then I'll get back to the questions that I see coming up on the channel. So now actually, in this case, I'm not actually going to say anything at all about the input list. I'm only going to say something about the output list. And I think I've introduced this for the first time actually when I've been talking about take, and I'm not really using this before. So if you want to give a name to an argument without refining it, then you don't use curly braces. Then you just use a single colon to give a name to an argument, right? So n is the name for nat, and xs is the name for the list of a's. And now what I'm going to say as a first approximation for the minimum is I'm just going to write an if-then-else statement. So which I have available in if-then-else expression. So I can just write in a slightly complicated way, if n is, so I want the minimum, right? If n is so length of, I think I can do it in both ways, actually. I'm not quite sure. Let's do this. If n is smaller than or equal to length of xs, then I'm going to say the length of rs is equal to n. Otherwise, I'm going to say that the length of rs is equal to the length of xs. Now I'm possibly running into problems with the parser. So the parser of Liquid Haskell is a little bit tricky sometimes. Or have I actually made a mistake? I mean, the other way is more natural to me anyway. Let me actually try this, where that goes to. But that's complaining about this as well. Or perhaps if then else is not actually directly available. Let's see. So one thing that I can do, I mean, I can also introduce a new construct is showing something for extending the language that you can use. So you would rather write this as minimum of n and length, what is it, and length xs anyway. So we can define our own minimum function. Let's do this. Let's hide minimum. And let's just do it on integers for the time being. And let's say xy, and then fx is less than or equal to y, and x else y. And then I can write inline min. And if this is sort of a function that is non-recursive and sufficiently well behaved, then Liquid Haskell will be able to allow you to subsequently use min in a predicate. So in this case, I should be able to say min n, so length of rs, I still want to say this, is the minimum of n and the length of xs. Let's try. Okay, that goes through. Yeah, I think the if and else may not actually be in the language. Perhaps I would have had to encode that using Boolean operators like or and. Oh, okay. I'm also seeing that. Okay, putting things sufficiently in parentheses also. I mean, yeah. As far as the parser, I can add a little rant. So there are lots of things that are bad about the parser, and I'm actually currently in the process of rewriting the parser, and there is a pull request which will soon be merged, which will fix all sorts of actual bugs. But there are also, next to the actual bugs, still a lot of just strange inconsistencies and actual ambiguities, which are a little bit harder to fix. So I think in the long term, it would be good to clean up the Liquid Haskell syntax a little bit, because I think like historically, to like in defense of the Liquid Haskell developers, historically the logic language was really pretty separate, and the idea was you have your own little sub language and that's it. And then they've added more and more of this functionality to put parts of Haskell into this logic language and to extend this logic language, and that clashes with the syntax that is already established for this logic language underneath. And now it would be better to kind of redesign this. Okay, so this is the other type signature for take, and you can see they both check, right? I mean, we don't have to do anything. The definition is actually accepted in this way, so that is very nice, and it's accepted in the other way as well. But they are very different, right? And one is much more strict and like pushing sort of requirements upwards, and the other one is like much more flexible in the inputs it accepts, but then it can establish less knowledge. And there is a real trade-off. I mean, it's not clearly one type better than the other, right? I mean, in general, if you want to have as much static information as possible and have your program be as clean as possible, probably the first one is better, right? But it also forces you to always establish this knowledge. And if you simply don't have it, then sometimes the second one is probably better. And for a library, it's not so clear which one you should be using. Okay, so let me look at all the questions that have accumulated, or perhaps Tim, you can if you have a better idea where I have to start, because I just have to. I think the first one is probably the, can you factor out LH types? Is that?
Yes, that was, I'm not sure whether it was answered. Maybe the question is whether you can attach these Liquid Haskell annotations to regular type synonyms.
No. Well, I mean, so you can of course still define a type synonym net in the Haskell world that is just equal to integer, right? Then you are back in a situation where you can like describe your intent in the Haskell world, and in the Liquid Haskell world it looks the same, but it actually means something.
Yeah, but there's no way to ensure that every time you use the type synonym net in the Haskell world, you also use the net Liquid Haskell type.
No, I don't think so. But for data types, you can. For data types, you can actually attach certain constraints directly to a Haskell data type and ensure that whenever you use a Haskell data type, that is the case. I think for type synonyms, it is tricky, right? Because the semantics of type synonyms in Haskell is very fragile, right? And a type synonym is supposed to be equivalent to an int, and the compiler can, at all sorts of stages, just choose to replace a type synonym with its definition. So you would have to be extremely careful that things are not going wrong if you wanted to attach some Liquid Haskell interpretation already to the occurrence of a type synonym in Haskell. I think it would just be very dangerous.
Yeah, makes sense. Another question. Is it possible to control which Liquid Haskell type synonyms are imported or exported from a given module?
I think, as far as I know, no. And I think that is another thing that is currently extremely, let's say, naively done in Liquid Haskell, unfortunately, this whole scoping of Liquid Haskell entities. And yeah, there is no good way of controlling the scope of things that you define for Liquid Haskell purposes alone. And it would be very much desirable, though, to have this. I think it's, again, something that is kind of natural, though, because it wasn't really very convenient or attractive up until very recently to do larger multi-module Liquid Haskell developments in the first place. So this is a need which is probably now going to be much more severe, and I would hope that at some point this is fixed, but I don't think this is currently possible. Next. Presumably, you could say something even stronger, saying the resulting list really is the prefix. That is a comment about the type signature of take again, I guess. And indeed, yes, I mean, you could try to be yet stronger, and indeed you could try to say something about the contents of the list compared to the other list, and that gets trickier to express, and I'm not sure whether it is worthwhile, but yeah, I mean, you could certainly try to do such things. And
so you can reason about lists, and you can reason about like non-simple types. Like,
yeah, you can to some extent. I mean,
level?
I'm not sure whether I will get around to demonstrate anything like this today, but yes, it's not impossible to do. It just gets much harder. I mean, it is still the sweet spot. Like if you compare Liquid Haskell to things like the type system extensions that Haskell already has, right? The sweet spot is somewhere slightly different, because clearly there are lots of things that you can get in a much easier way than if you would try to establish the same properties with like things like GADTs or stuff like that. Already, because you have a very, very rich theory of integers available in a system such as Z3. And we have seen this already to some extent by just being able to like add numbers and like calling tail 3 or 4 times and just adding these things up and saying the list has to be longer than 4 and using actual numbers and not piano naturals and anything. And there's more, right? You have associativity and commutativity and distributivity on a symbolic level, and all these kinds of things they just automatically hold, and that is very convenient. But at the same time, of course, you have certain types that are very well supported, and integers is one of them, and sets is actually another one of them, which is also quite powerful, and you can do a lot of stuff with that. But like if you're outside of these types, we can still do a lot by mapping into them or reusing some of that theory. But if you're really completely outside of it, you're in a much weaker realm again, and then it doesn't necessarily become harder, but you're losing like quite a few of these advantages that you initially have. So that takes a little bit of time to get a feeling for what's easy and what's difficult to do in Liquid Haskell. But by all means, I mean, it's absolutely a valid remark that you always have yet more options. I mean, nearly always you have yet more options. I mean, of giving yet more precise types. Then there are comments about. Okay, so like, yeah, I mean, I think all these questions about other ways of writing minimum, I think, yes, they probably work. I mean, my problem was, I think, getting it through the parser, not that it doesn't actually work, and expressing it using and or and something like that is certainly also possible if you want to. Then there is a comment about colon and double colon. I think that is, it's not so clear cut, right? I mean, if you just look at this, right, then you have take colon, colon, n colon, colon, nut in the beginning of the line. That's not necessarily much nicer either. And then you can say, okay, then let's require parentheses there and so on and so forth. I mean, I think, yeah, I mean, there is something to be said for Haskell has now adopted this double colon for is of type. So let's stick with that here. But it is a slightly different notion. It is sort of like, it's never used in the expression has a type situation where in Haskell it is also being used, right? And in Haskell you can use colon, colon to give type annotations to expressions. It's always used in this asymmetric form where you have a single identifier on the left and give a name to something of a particular type. I think in that notion you can get used to the fact of using a single colon here, but yeah, I mean there's certainly things to be said about all these design decisions, and they could have been done differently. So then Wolfgang is making a comment about that strict take can be defined in terms. That is actually something that surprises me right now, but actually in this case, contrary to my earlier statement, that is actually possible, yeah, because you are still, if you're doing the loose take and you actually have the knowledge in addition that the length is greater than or equal to the number, then you can recover the strict type from the other one. That is in this case actually possible. I originally thought that they were incompatible, but there are other situations where you have two different types which are really incompatible and none is recoverable from the other. And then of course you would have to repeat the definition, because Liquid Haskell does not look inside, right? I mean, if you're writing it like this, it starts from, if you're writing strict take equals loose take, it starts from the type of loose take. Okay, there's more questions. If I use the first specification of take, shouldn't I be able to remove the first equation dealing with I less than or equal to 0? That's a good question, and so let's actually just try it. What happens there? I think there's also already discussion about this, but nevertheless, it's perhaps good to try this. If we now if we say, okay, the length now has to be greater than or equal to n, couldn't we remove this case here? But then it's starting to complain, and if we think about it, okay, so it's going to say this I minus 1 is now no longer guaranteed to be a natural number, because it could actually be 0. With a non-empty list in this case, we would reach this one, and then we would call take with -1 on excess, and we would run out of things. So I do think we need a case for 0, but we don't need a case for less than 0. And if we take this, we could change this line to equal to 0, and then Liquid Haskell would still be okay with it, right? Because that is really what we ruled out now, that we can have numbers that are smaller than 0, but we need the case for 0 because it's not covered by the others. So then there is a remark, simply by trying it out, liquid type synonyms are dependently typed. So you can write something like, yes, you can parameterize Liquid Haskell type synonyms both over Haskell types and also over other entities like the natural number. So we could write that an integer is greater than something. So greater than n. And I think I'm not sure whether it's required, but at least the convention is to use an uppercase letter in a Liquid Haskell type synonym if this is a logic term, essentially, so something that lives in the predicate language and not a Haskell type. So in this case, this is a number that is supposed to be used in a predicate, and but then I could write n as n, so and n is strictly greater than n, something like this, and then I could use GT3 as the type for numbers that are strictly greater than 3. That is possible, indeed. Then there is a comment. Okay, that's just a comment by Oleg, I think. Then there's a question by Gabor. Can Liquid Haskell import user-defined types? I'm not sure what you mean. Could you just, if you're in the call, could you just say what you mean?
Yeah, I mean, as you can inline min, the function min,
Yeah.
can you inline also data definitions to a limited degree?
I can start defining my own data definitions, and I can still do things with them. And I mean, of course, I can use them like in the types position. But if you mean that if I can use the constructors or something like that, then the answer is to some extent yes. I mean, so essentially, I think as long as like things built from constructors are to some extent possible, yes, but not arbitrary functions unless you take special steps. I mean, inlining is possible for non-recursive things. There's also a reflect construct that works for recursive things, but is going too far at this
I'm
point.
mainly interested in whether you can write a type definition, algebraic data type like weekday, and then use that in the oh no, it should.
Yes. Okay. So that's a good question, and I mean I can show that. So that is not going too far at this point. So let's. Okay. So what you can do if I do something like this, I can define weekday, which is a weekday, and I can define weekday to be Saturday, and I can, for example, do something like type weekend day or something like that is a weekday where the weekday is Saturday or Sunday, and then I should be able to say that the weekday is a weekend day, and that works. So and this again, this is a word of warning, right? I mean, this is not the Haskell equals. This is sort of the logic equals, and that is actually available to you in here, and you can refer to the constructors of the data type, and that is something that you can say. And so in that sense, you can do simple things with your own data types, even without going to a whole lot of effort. And this this sort of stuff is quite useful. We're getting a little bit out of sort of the natural order of things, though. If I go too far into this direction right now, I mean, I would probably get back to something similar to this later if we have the time to look at this. So I'm wondering whether people would like to just go on for the full 3 hours and like use as much time as possible, which is fine with me, or whether there would be a strong preference for having at least sort of a short 5 to 10 minute break in between, because it's roughly half time now, I think, isn't it? So so if a break, then now, I think. And yeah, let's keep it relatively short, perhaps. Shall we meet again at the full hour, like in 6 minutes? Is that fine? Okay. And if there are more questions in the meantime, then I'll just be gone for like perhaps 1 minute or so, and be back and try to look at questions, perhaps, but not do anything new. Okay. Then I would continue now. I don't currently see any additional questions, so I'm assuming that you're okay. So to look at a slightly larger thing, I wanted to look at sorting, right? Because it's like a nice realm and it's not too complicated. It's relatively simple to do, but there is a lot of stuff to show in that context about how Liquid Haskell works. And I want to look at a number of different sorting algorithms and see like what kind of features they need in the context of Liquid Haskell. And the first one I want to start with is insertion sort. And insertion sort, as far as Haskell is concerned, let's actually just write this, is based on a function insert, which of course with an OR constraint takes an A and a list of A to a list of A. And if we try to insert an X, and the idea is, of course, that insert here, that this is an already sorted list, right? And that we get another sorted list out. I mean, that is the basis of how insertion sort works. So if we insert something into an empty list, then we produce the single element list with just that X. And if we insert an X into Y comes YS, then we have to look at whether X is less than or equal to Y. And if it is, then because we are assuming the list to be sorted, then we're done. Then we can write X cons YS and everything is fine. Right? But if X is not less than or equal to Y, then we know that Y must be the first element of the resulting list, because Y is clearly ending up in the very beginning. But then we still don't know where X fits in YS, and we have to recursively call insert X YS. Okay. And then once we've done that, insertion sort is very easy to write. Actually, the easiest way to write insertion sort afterwards is, I guess, as a fold R, where we just say insert and the empty list. Right? So we start with the empty list, and then we go through the entire list and just insert every element rather than cons it. And then because we start with the empty list being a sorted list, if insert preserves this invariant that takes a sorted list to a sorted list, then in the end we should be fine. So that's good, right? Now, obviously, it would be tempting to actually be able to make this precise in Liquid Haskell, that like insert goes from A and a sorted list to a sorted list. And of course, again, we have a whole range of things, right? If we want to talk about like fully specifying insert, then we should be saying even more, in particular about the elements. I mean, about the lengths, like the resulting list is one element longer than the original list, and also about the elements, that actually the resulting list contains exactly the elements of the original list plus the new element. But let's perhaps start with this notion of sorted list. And I'm going to do this in a number of steps in order to show a few different features. And first, I'm going to show how we can do this by introducing a new data type for sorted lists. Okay. So this is our first approach. Is going to be we are going to introduce a new data type sorted list, which has exactly the same structure as a normal list. So let's call the empty lists nil, and let's call the non-empty lists, let's do some sort of fancy less than or equal constructor that indicates that we want this to be ordered. And then the tail should be a sorted list of A again. Something like this. Okay. Now, we want to make it clear that whenever we are using a sorted list, we actually have one that is sorted. And how do we do this in Liquid Haskell? By giving a Liquid Haskell version of this data type declaration as well. So this is optional, right? So you don't have to give a Liquid Haskell version of a data type declaration if you are happy with the Haskell version, right? So you can use the, as we've seen in the weekday case, you can use the, even with just the Haskell definition, you can use the type in certain ways already, right? But now we actually want to refine the constructors themselves. And that is something we can do by making a copy of this definition. And now again, this is again a parsing thing. There is something very strange going on in the current Liquid Haskell parser for data types if they are not in record notation. And this is going to be fixed after my pull request makes it in. But for the time being, I would advise, I mean, there is ways again with additional random parentheses to get around this, but I would advise to just like give all Liquid Haskell versions in record syntax, and Liquid Haskell does not mind, and in fact it is even useful to have names for the components. I mean, in this particular case, it's even particularly useful to have names for the components anyway. So in many situations, this is good anyway. So let's call this head for short, this A, and this tail. So this is a starting point. This is accepted, okay? But now, can anyone see what we want to do for this list to be sorted? I mean, perhaps not what we want to syntactically do if you haven't seen that before, but what we want to conceptually say. Several people are typing. Yes. All elements in the tail should be greater than or equal than the head element, exactly. Okay, so how do we write this? Well, we already have a type here for the tail, which is sorted list of A. We can refine the A, right? Rather than saying the tail is a sorted list of arbitrary A's, we can say that the tail is a sorted list of such A's, let's call them X, that the head, and there I can actually just, this is why it's useful to have given it a name, I can actually just use head here without any argument, is less than or equal than the X. Okay. And now this is a type of sorted list. And let's see whether that actually works as expected. So let's example sorted. So there's a question, how does that account for nil? We'll discuss that in a moment. Let's first see whether or that it works. Let's say, so example sorted. So I'm hoping this to be a sorted list of ints, let's say, and let's say 1, 3, 5, nil. And this type checks, okay. And now let's try perhaps 1, 5, 5. That's also okay. Let's try 1, 6, 5. That's not okay. And it's actually not okay after the 6, right? Because indeed, like 5 cons nil is still a valid sorted list, but we cannot use it as the tail for 6. because it does not exclusively contain elements that are greater than or equal to 6. So now the question was, how does that account for nil? I would argue it doesn't really have to, right? Because nil is fine as a sorted list, as an unconstrained sorted list of any A still, I mean, right? Regardless of what kind of bounds you would have, nil is always okay on its own, right? And if you're looking at just this last case in isolation, let's make it type correct again, at 5 cons nil, that is also okay, because 5 is there, and then we're saying the tail has to be a sorted list of integers that are all at least 5, but if there aren't any integers, that is going to be still okay. Then there is a question, how does this account for strictness problems? Does x colon a head is less than or x imply x is not equal to undefined? If you say so, it does. I mean, so undefined is, I mean, the way that the current liquid base works is undefined is still left, I think, at its unsafe for all AA type, and gives you an escape hatch. So I think if I place undefined somewhere here, it's actually going to be fine. That is sort of a pragmatic decision to still, like, because error is already excluded, to still give you some option to just briefly discharge something and say, like, I want to worry about this a moment later, but of course it is utterly unsafe. But if you would give undefined a type that is essentially making like a more restricted type, or just remove it, then it wouldn't, I mean, it wouldn't work, right? I mean, because you cannot, like, at least within totality, you cannot define your own version of undefined if it's not already there. I mean, I'm not claiming that Liquid Haskell is in that sense sound. I mean, there are certainly options of evading that, but at least, I mean, conceptually, right? I mean, functions are supposed to be total. So if you try to reproduce undefined in the way you would normally do it by writing loop equals loop, you're going to get a termination error, right? So so it's not as if you can easily just create your own version of undefined, but the predefined undefined is typically allowed as an escape hatch for pragmatic reasons. That's an interesting question. What about 2 less than or equal undefined less than or equal 1 less than or equal nil? I can basically give that right back. What do you think? I mean, I'll try it and I'll explain it, but I mean, still, what's your intuition? Like, should that work or should that not work? I think with the stuff that we've already discussed, you could probably say, would this type check or would it not type check? There is a reply. Let me look at the reply. The guess is it's forbidden. So let's see whether the guess is correct. So this is actually allowed, but I must say that I'm myself slightly surprised. I would have, I mean, yeah, okay. So I would have said it should be forbidden as well. I'm not sure, because my intuition would have been that undefined is available at type A, right? But this whole list is still going to be forced to be a list of things that are greater than or equal to 2. And so we still reach this point. Oh no, but because undefined is A, it can be no, but nevertheless, no, I don't quite know, to be honest. I have to declare that I don't know. I will try to figure this out. I would imagine that there is something strange going on specifically for undefined. So I mean, it reveals that it was all the more a good question because you managed to surprise me. Let's go on to the next. So how about something like, now I have to look at this carefully. Sorted list x0a. So that's a good question. So the question is whether we could parameterize over the integer in that we are trying to be larger than, if you could introduce additional parameters. I will say something in that direction later, but I would like to defer that slightly. And Martin is having some theories as to why the undefined is going wrong, but and then there is a comment about the GHC IDE plugin. That is interesting. I mean, I think I've had that once that it stopped working, but I mean, I do sometimes try this as well. So this is certainly a good reflex. Don't trust the, like if you're working with some sort of IDE support at the moment, don't trust this all too much. If you see something that is really strange, then verify that you're getting the same error or the same behavior in GHCI, but at the moment we are. So let's see. Okay, no, let's go back to one that is actually okay. Let's leave one that is actually okay. Now, let's try if we can rewrite insert to use sorted lists. And let's do that just by copying insert and then changing the name. And then working on sorted list of A. And then of course we have to like change all the constructors here as well. So this is nil, and this is x nil, and then this is y like this, and then this is also this and this, and this is also this, and then it works without any further changes. But let's briefly think about why. Because it's not at all so trivial that it actually does work. So in particular, perhaps as a good question, there is, I mean, Ranjit has been writing a blog post half a year ago or something like this about particularly this case. There is an interesting variant of this function that does not type check. And perhaps I can ask that to you, whether you can figure out why it doesn't. So let's do yet another version of insert. And let's just monomorphize it. So this one is working for all types A that are in ORD A. And this one is monomorphic for ints. And this
But
one
Andres,
is
you haven't written a Liquid Haskell signature for insert prime yet.
No, that's a good point. Thank you for pointing that out. I don't have to, because this goes back to what we earlier discussed. Like, can you attach Liquid Haskell refinements to Haskell type synonyms? And I said no. For type synonyms, you cannot, because type synonyms are sort of too fragile in the Haskell semantics. But to data types, you can, right? So we have given a Liquid Haskell refinement for the data type. And this now means that just by mentioning the data type, right, Liquid Haskell will check that what we've written here for the type of the cons constructor is correctly applied. And actually, perhaps even before we go to the wrong version, I can show you that it's really checking this. If I'm, for example, what might be a tempting sort of mistake, if I'm forgetting to do the recursive call here and just say, well, either I put the X first or I put the Y first, but I'll leave the rest out, then I'm getting a type error, which says that this is not correct, because I mean, this is not necessarily sorted. And if I insert prime, or if I what's another thing that I could do wrong, if I flip the Y and the X here, right, then this is also going to be wrong. So all these things are now actually checked. Right? So just by mentioning the type, so that is very nice. If we attach refinements to a data type itself, again, of course, we're possibly getting into situations where, like, I mean, this is too strong. I mean, but I mean, in this case, we have deliberately introduced the Haskell data type in order to do the refinement. So there, it doesn't really make sense. I mean, if we were forced to change our standard list data type to now always mean sorted list, then of course that would be very inflexible. But for the time being, this is okay. Later on, I will show how to do this for ordinary lists. The same thing, how to get away without introducing our own sorted list data type. But this is an intermediate step that is helpful. And okay. Well, so overflow nastiness is pointed out as a possible reason for why insert double prime is not type checking. So in fact, I mean, I'm going to stay out of this discussion, but there is there's also a blog post by Ranjit Njala where he's talking about like the reasoning behind the way that overflow is handled or not handled in Liquid Haskell. So so a lot of stuff is not true in the context of overflow, right? And a lot of equations that Liquid Haskell is able to prove are not actually true in the context of overflow. So essentially, the assumption that Liquid Haskell makes is that by default, integers are not overflowing. You can yourself make a subtype of integer that is bounded, right? Where you explicitly introduce, if you want that, where you explicitly introduce an upper bound and make sure that you're not reaching that, or a lower bound and an upper bound in the range. So you can still express something that cannot overflow, but the default handling of integers is as if they don't overflow. So that is not the real reason. So let's see further. Aha, so Martin is making a remark. Yes, I think that remark is spot on. So so if we look here, if we just look at what is insert even doing, what kind of reasoning does it have to do? And if we go through all the interesting cases, let's just see. So this case is relatively unproblematic, right? Because we start with a list that is trivially sorted, and like prepending anything on nil is always going to be sorted as well. So here, by pattern matching, we're essentially learning that everything in ys is greater than or equal to y, right? Because this is already a sorted list. And now we're additionally learning that x is less than or equal to y in this case. And then this is going to be fine. By transitivity, everything in ys is also going to be greater than x, and y is greater than x. So everything in this list is greater than x. So this is okay, Right? Otherwise, we know that x is not less than or equal to y, so that x is strictly larger than y. Right? So y being smaller is fine. But now this insert call, why does it produce a list of things that are all greater than or equal to y? Well, that is because we have a polymorphic function here, which we can instantiate at a refined type that says that we want to call this only on a's that are greater than or equal to y's. And then so now we have to check that x is greater than or equal to y, but that is the case because x in this case is actually strictly greater than y, and that everything in ys is greater than or equal to y, but that is already following from the pattern match, right? But we need to do this instantiation of a to a refined type. And in order to be able to instantiate the a to a refined type, we need the a to be, at least to some extent, polymorphic. Right, and in the monomorphic version, where we say that this is int and nothing else, we simply cannot. And then we cannot learn enough about this recursive call of int. There is still a way to recover this. And that is going into the direction of what I want to briefly talk. I can't go into very much detail today in this workshop about this sort of stuff. But there is a thing in I mean, the general concept is called abstract refinement. And the idea is going into the direction of what I think Gergo asked earlier already. Like, can we abstract from certain things in data types or in other things as well? So, and indeed, we can introduce just the amount of polymorphism that is needed here while still keeping the int type around, if I can get the syntax right, by essentially writing for all, and then a strange parenthesis, angle brackets parenthesis. Don't ask me about these syntactic choices. And then we give a name, and then this is a double colon, if I remember correctly. Again, I don't entirely know what the reasoning here is. And then we want something that goes from int to bool. So essentially a refinement on integers. We want to abstract over an additional refinement of integers. And then we're going to say, this is an integer that can be refined by p. And this is a sorted list of integers that can be refined by p. And this is a sorted list of integers that can be refined by p. I'm not sure whether these parentheses are needed, but I like to put them there just for emphasis. And then this goes through, because now it allows us to instantiate this function insert essentially to int and all its refinements. And that is good enough again. Right? And that is a way to abstract over possible refinements of a type. And you can do this in other situations as well. And that is also something that will ultimately help us when we want to use the standard list type for this. Yeah, this the question is, oh well, there's probably other questions in between, but the last question that I'm just seeing by Etzko is that this angle bracket syntax is specifically for predicates, and that is right. I think there is even, so I'm not entirely sure whether you could abstract over other things. I don't think Liquid Haskell allows this at all at the moment. If you wanted to abstract over something that just has integer types, I think you're already getting an error here that is not even just that you're using a type incorrectly, but it's saying exactly that you are using some sort of proposition variable or proposition type, but it doesn't have a Boolean result. So this is limited to predicates, but it can be predicates with multiple parameters. And indeed, in this application form, it's also like limited to predicates. Let me briefly check whether there are other questions in between that I have overlooked. Let's see. Okay, yeah, there are a couple of interesting questions. So one question is, how exactly is the term level overloaded less than or equals connected to the less than or equals function? So in general, yes, indeed, all the operators have types that connect them to the logical values. So perhaps even easier than less than or equals is something like plus. If we look at plus, and if we even just restrict it to integers for the time being, do not bring the overloading aspect into it as well. But we are seeing, like, just looking at what would be the type of the plus operator, right? Sorry, of the plus operator. Then the right way to write this in order to essentially connect it up would be to say we're taking an x of type int and we're taking a y of type int, and we're producing a z of type int where z is equal to x plus y, right? And this is essentially doing the linking up, because this is a different plus, right? One that already exists in the logic language. And here we're saying, okay, the plus function, so the way we're writing it now, is exactly establishing that its result is like equal to the sum of its two components. And of course, the way that this type checks now already presupposes that plus already has this type. But assuming this was a primitive thing, then what Liquid Haskell allows us to do is to say assume, rather than just giving the type signature. And then it would not check this definition, and would just assume that this type is correct. And this is actually something that is very useful if you want to attach types or more expressive types to libraries that you don't want to like prove correct, but you want to still make it easier to use them in a correct way, or perhaps make sure that certain wrong ways to call functions can no longer be exploited. And if you do this, you can basically just take the public library interface, use assume to attach type signatures to it that establish certain additional invariants or properties, and have them properly checked by Liquid Haskell.
There's a follow-up question. So does that mean that the liquid base version of the ORD type class has these annotations? So all user-supplied instances will have to match the SMT solver defined less than or equal?
Yes, I think that it does basically mean that you have to make sure that your ORD instances are well behaved as far as the SMT solver thinks so. Now, again, like how type classes exactly are handled within Liquid Haskell is some sort of moving point. And there is quite a bit to be said about it, and I'm not familiar with all of it. There have been some papers recently, and there is also a huge branch which is not yet merged, which revises and extends the type class handling and makes it supposedly better. So I'm not quite sure about the trade-offs involved at this point right now, whether one can sort of like explicitly opt out under certain circumstances or do something. But it's certainly something to be careful about, right? I mean, indeed. I mean, I think the standard way of doing this is that Liquid Haskell will assume that everything that supports less than or equal, or everything that supports even just equals, that the equality will have the properties of at least an equivalence relation, and that the ordering will have the properties of at least, I'm not exactly sure, but of at least a partial ordering, if not more, right? And if you write anything that violates these, then you might be able to prove very strange things. I'm still thinking I may have overlooked questions in between. Let's just see.
I've marked the unanswered questions just with a question mark and
okay. So I'll
tick if they have been answered.
Okay. I think the other one by Gergo is very related. Yeah, okay, so then. But the last one, are you also using assume when reading a value from the outside world, e.g. using readln? Well, that's not what I would be doing. So if you do readln, right, which is a function that is of type IOA, for A being in the read class, and what it does when executed, or it's not a function, it's an IO action. If it's executed, it reads a line from the user and then tries to convert it into a particular value via read. But let's perhaps more generally look at getLine rather than readln immediately. If you're reading an arbitrary string from the outside world, then at first you don't know anything about it, right? So it would be very, very strange if you started doing assume at that point. So what you're supposed to do also in your code anyway is to run some sort of sanity check, right? And the sanity check is supposed to like establish certain properties. And now you can, like a good, like even on plain Haskell, right? Or that's like, well, let's just call it check. If you have some untrusted input, like some untrusted string, the good type to give to something like check would be at least string to maybe, and then some other type, right? Perhaps email address or something like that, where you're saying that I'm not just going to use a string to represent an email address, but I'm going to perform an actual function on a string that changes the type. And if I'm successful, I'm getting a new type back. And that's the right way to do it, not to assume something about the string in the first place. Now, what you can do, if this check is very complicated, right, and you want to establish certain additional properties, like here, and refine the type of this, you can assume a type for this check function that perhaps says like something more, that I'm saying like, okay, I have really, really very carefully looked at my check, and I want to like make certain additional assumptions about what this check establishes. And then Liquid Haskell will keep track that you're using these sort of assumptions consistently, right? But don't make assumptions about untrusted values coming from somewhere. That is not a good idea. I think I cannot completely answer the question by Oleg about whether like something like less than in the logic language works for any type. So as far as Z3 is concerned, there is a concept of sorts, which is sort of the Z3 equivalent of Haskell types. And the sort language is very simplistic compared to the Haskell type language, and there's certainly no such concept as ORD as a class. And so it is much less clear, but I'm not sure whether actually it works for all types in Z3, or whether it's just somewhat fuzzy. I don't know. I'm afraid I can't fully answer that. Okay, let me try to go on. We have about 50 minutes left. Do I see that right? Okay, let me try to do a few more things so that we can see a few more interesting things. So one more thing that I wanted to show now, I mean, of course, we would like to complete insertion sort. We haven't actually done this. So, so insertion sort before was written using fold_r. And the question is, can we still do this? Can we still write insertion sort using fold_r on our sorted lists? Well, I mean, sorry, no, the original list would be A, right? And the resulting list would be sorted list of A. Okay. Now, I have to replace this with insert prime or insert double prime, and I have to replace this with nil. And then it just works. And this is perhaps a little bit surprising, but it is actually the case because we are not trying to prove anything particularly strange here. We are really instantiating fold R according to the way in which it is parametric already, right? If you look at the type of fold R, then the type of fold R is A to R to R to R to list of A to R, right? And what the instantiation that we're using here is that R is a sorted list, right? And because insert just has the right type, that insert takes an A in the sorted list of A to a sorted list of A, it's really an instantiation that follows along these lines, right? If we now wanted to prove, for example, that the length of the sorted list is the same as the length of the original list, then we would be out of luck. So if we try to give this a name, and we now say this is the resulting list, and the length of the resulting list is equal to the length of access. This is, oh yeah, no, I made this mistake again. As I said, this is very tempting to just take the Haskell type signature and edit it. Then this is going to fail, right? And why is it going to fail? Well, simply because now, if we look at the type of fold R, and the type of fold R is like this still, even in liquid base, right? There is simply nothing we can say about the result type that varies with every recursive call, right? In this particular case, we would really, like, all our sublists are shorter, right? They have a different length, and we would have to do an induction over the length of the list. And it is actually possible to write a version of fold R in Liquid Haskell that allows you to do this and to write the insertion sort still using fold R. It's one of the things that I could be doing. I think I'll probably make a little poll now what we're going to do in the remaining time. It's one of the things that we could be doing. But with the current fold R, we cannot prove this extra thing. So sorry, made everything incorrect. Let's go back to this. So this is still saying that the list is actually ending up being sorted. And there's still the way of expanding. If I would expand the fold R, Liquid Haskell would also be able to show that the length is maintained, because for insert, of course, at the moment, we're not even proving it for insert, right? Yeah, okay, so that's an additional issue. But even then, I mean, for insert, we would at least have to start. That could be the first start. We would have to do this for insert, that the length is incremented by 1. But then we don't even have a length function on sorted lists right now. So let me actually perhaps not go there. I'm just, yeah, that was a little bit glossy. So let me just recap briefly. So if we wanted to additionally prove that the sorted list has the equal length as the original length, then what we would have to do consists of many steps. So first of all, we would have to actually introduce a length function for sorted lists, so that we can reason about the length of sorted lists. And then we would have to prove that insert increments the length of the sorted list by 1. That is very easy. That follows directly from the definition, that there's nothing more to do there. And then we would have to prove that isort maintains the length. And that is also still very easy if we expand the fold R and do explicit recursion, and then Liquid Haskell would be able to see that. But if we want to do it using fold R, we would have to write a more general induction principle that allows us to establish such invariance. Yes, right. Gergo was pointing this out, that I have been also not even defining a length on sorted lists. So, so multiple directions that I could be going in. So I think it is relatively nice to show like how we can like do this using the normal list type instead. That is one option, rather than the sorted list type. By showing like how you can, like in a slightly unusual way, refine the normal list type to get the sort of property in, and also to show a little bit more about how you can abstract over predicates. That is one option. Another option is we could look at merge sort. Merge sort is interesting for a completely different reason, namely because it has a slightly unusual form of recursion, where it's not so clear for the built-in termination checker to see that that the merge function actually terminates, and we can talk a little bit about how you can deal with termination in Liquid Haskell in that context. And yet another option is to that's the third option. So I think Tim is putting them on Slack, like with option colon, and you can vote by putting reactions on these. The third option is to look at like to leave sorted lists and integers behind, and to look at sort of a classic like Hutton's razor simple arithmetic expressions domain-specific language, and show a few things about that one. I think we are probably only really going to manage to fit one of these three things in. So I'll give you 2 minutes to vote.
So option 2 isn't there yet, right? I want to vote for option 2. It's not there yet.
Option 1 is further up, which has no votes at the moment. Normal list type instead of sorted list type.
Oh, right. So that's about parameterization over.
Option 2 is look at merge sort, and option 3 is sort of not Occam's razor, Hutton's razor. So that is arithmetic expressions that start out with just integer literals and addition, but we add in a few more constructs. And indeed, there are 2 possible options, even sub-options there. I wouldn't go to lambda calculus terms with scope safety, but I could do like arithmetic expressions with let and do scope safety for those. Essentially, that is something that I could do in that context. So of course, option 3 is a disadvantage because it's the most recent one being listed. So I think at the moment it's a rather close race, but merge sort is in the lead.
We need to start campaigning.
Hmm?
We need to start campaigning.
No, it's fine. I'm happy with all of them. I mean, still a close race, but merge sort seems to be winning. Well, how can the count go down? Somebody removed their vote for merge sort. This is very funny. Okay, so we should be doing everything, I see, because nobody can decide. So it's a tie.
I'm sorry, what was the first option again? What does it mean, normal list instead of sorted?
I think I'm going to like call it for the merge sort, which was in the lead for the largest part of the time, even though, I mean, I think the expression language would be very interesting to do as well, but there's only so much that can be done. And I will actually do a short version of option 1 by just showing you without going through the intermediate steps, because I don't want to do merge sort on the sorted list type. I want to do it on the real list type. So the way you can write a sorted list in Liquid Haskell directly using just a normal list type is by using the list type and then placing one of these brackets here, because the list type itself has a parameter, it's one of these predicate parameters. And then the thing that you can put here is a function that takes two a's, right? X is an a and y is an a, and you can say in which relation they should be to each other. And you can say, for example, that x should be less than y. And the idea is, where is this applied? If you look back at the normal sorted list type, also I'm missing the a. If you look back at the sorted list type that we've been saying, you can see here that essentially what we're writing down here is a function from two a's to a Boolean, right? Namely, a function that gets the head, a function that gets all the elements from the tail, and that needs to result in a Boolean, which says whether this is correct. And this is exactly the function that this syntax that I've given down here allows you to fill in. So this amounts to the same as what we've been writing for a sorted list, where we're saying that like whenever we're in a cons and the first element is x, and y is any element from the tail, then this has to hold. And you can put arbitrary other things in there as well. So you can, for example, define a type of lists where every element has to be exactly the double of the element before, or something like that, or has been at least as large as the double of the element before, or all sorts of interesting properties. So that's
Is there stuff missing here? It just says for any x and y. Surely that can't be true.
No, I said whenever you are in a cons constructor, right, and x is the first element and y is an element from the tail, then
And where did you express the cons part?
That is the part that I'm now not showing, where like I could have shown how to generalize the definition of sorted list by introducing a p parameter which has this type and abstracting this thing out. But essentially, we are introducing a parameter p that goes from a to bool, and we're using it in this place, applying it to head and to x.
So what you're using is a definition from the liquid base library, right?
Yes, yes. This is, well, actually, in the case of lists specifically, I'm not actually sure, because lists are always like, they have magic syntax, of course. I'm not actually sure whether that definition is anywhere in Haskell code or whether that is hard coded in Liquid Haskell. But because of the list type and magic syntax and everything. But in principle, morally, it belongs in base, or even in Liquid GHC prim, which Liquid base depends on. Anyway, I mean, so even if you're not fully comfortable with this syntax, right, the way that we can use sorted list prime is exactly the same now as before. So if I just write 135 or run something like this, and I give it a type signature. Now in this case, it's a type synonym, right? So not a data type. So now I actually have to like do something where I can leave it as integer, but I need to put a Liquid Haskell type signature on. And I have to say example sorted list prime of integer. And this will work. And if I put a 6 here, oh, then it will not work. I was worried there for a moment, but it came around. So so that that's nice because now I can keep using the ordinary list syntax and it just behaves as before. So there is a question by Gargo. One of the examples was the list elements keep doubling, but for that. Oh, well, no, I was thinking about the least, like the less than or equals, not as the exactly equals. So you're right. I mean, if I wanted to like say it's exactly doubling, then it would probably be difficult. But if I'm saying that all the subsequent elements have to be at least double of the current element, then it's going to be fine. But yeah. You can still find constraints that are not expressible in this setting, but there is quite a few things that are expressible with this sort of constraint. Okay, so now the idea is to do merge sort. So how does merge sort work? Merge sort works by splitting a list into two halves repeatedly. Right, if you have a list that is like sufficiently short, like 0 or 1 elements, you return it immediately. Otherwise, you split it into two halves, and then you like you call merge sort on it recursively, and then once you've like sorted the two halves, you merge them together. So the main operation, perhaps, or we have to, oh well, which one is the main operation is perhaps in the eye of the beholder, but we have to implement two operations. We have to implement merge, which takes two sorted lists to a new sorted list. And we have to implement split, which takes a list and splits it into two halves. And so let's do merge first. And merge is like this, and I'm going to give it type which says that we're going to operate on sorted lists now. And how does this work? Well, if the first list is empty and the second list is not, and both lists are sorted, then we can just return that list. This is at the moment complaining that it's not exhaustive. If the first list is non-empty and the second list is empty, then for the same reason, because both lists are sorted, we can just return the first list. Then we still have to consider the case that both lists are non-empty. And then we have to look, is x less than or equal to y? If that is the case, then it is safe to go on with x. And then we still have to merge xs with y cons ys. Otherwise, we continue with y, right? Because then y is less than x, and then we still have to merge x cons xs with ys. Okay. So now I'm actually getting a type error rather than a. So, but I'm wondering whether this is a termination error in disguise. So, I mean, it's possible that I made an actual mistake. Let's see, but it's also possible. So the problem here is, right? I mean, the termination problem here is independently of whether there may be other type errors still ongoing. The termination problem here is that typically, like the naive termination checker is doing some sort of structural checking, namely that, like, for example, if we have an argument that always gets structurally smaller in every recursive call, then if the type is well founded, then there must be termination, right? So if, for example, if we have a list and we have a case for the empty list and we have a case for a non-empty list, and we do a recursive call on the tail of the list, then it's impossible to not terminate on a finite input list. Of course, if we put in an infinite input list, then we're asking for it, but on a finite input list, we'll terminate, and in particular, we'll make progress in every case, and the list will get smaller. But here, the situation is more complicated because xs is not always getting smaller, and ys is not always getting smaller, right? Sometimes xs is getting smaller, and sometimes ys is getting smaller. So, so what Liquid Haskell allows us to do in order to satisfy the termination checker is to specify a so-called termination measure for a function, and that is done by writing something after the type signature. Again, one can argue about the syntax of all of this. This is all like, I mean, I don't quite like it because it's done in a way that like steals a lot of syntax that may still be useful for other things, but there is this slash, and then you can write a list of integer expressions essentially that are supposed to be used as a termination measure. And so what does that mean? The correct measure to use in this case is len xs plus len ys, where xs and ys are the names of the input functions. So the idea is that xs is not getting smaller in every recursive call, and ys is not getting smaller in every recursive call, but one of them always is, right? So if you take the sum of the two lengths, you'll now have something that is always of a natural number value, right? And is actually strictly decreasing in every recursive call. And that explains why the function does terminate, because it's a natural number, so it always stays above at least 0, and it is always getting strictly smaller in every recursive call, so you must terminate at some point. And you could put like comma separated, like in the list syntax, could put more natural valued expressions here, and then it would be lexicographic. So the idea is that like either the first one has to get strictly smaller, or the first one has to stay equal, and then the second one has to get smaller, and so on and so forth. But this is a way of explaining sort of strange termination mechanisms to Liquid Haskell, and to justify that such a function terminates. So there is another question. Would merge?
Yeah, that's basically the question about lexicographic termination checking.
Yes, so my question is, if you had an S pattern match on const x-axis, then there would be no increase from axis. Would that help?
Yeah, so I mean, so I'm not sure whether your question is also the same than the other two. I mean, the question by Etzko and by Gabor is whether you could use lexicographic sorting between length xs and ys in this case, because xs doesn't actually ever increase. And yes, you could.
No, my question is, if you didn't add, so before you added the termination proof or the termination measure, right? It wasn't accepted because automatically it wasn't inferred that it's gonna terminate, right?
Right.
So my question is, if instead of rebuilding,
oh no, okay, I see it. Okay, I see it. You want this, and then you want me to use this. This is not going to be
so
enough.
it doesn't change anything, you're saying.
And in fact, why does it complain now? This is actually interesting. Why is it now even complaining? I mean, first, let me explain why it wouldn't fix the termination issue. I mean, the termination issue is not fixed because the problem is not that you're rebuilding the list. The problem is that the list is not shorter than the original list. So it is already taking into account that this list has a particular length, which is the length of xs plus 1, and you're calling it on another list again, which has the same length and not a strictly shorter length. So whether you're using xs0 or reconstructing it is not relevant for that. Now, why it's complaining now that xs0 is not even correct, that looks like a bug to me. I mean, I cannot currently judge why this is. I'll have to just defer this, I think, to like look at it again later. Sorry. Well, you could certainly make the default better. I think the default is that there has to be a single argument which is decreasing. I think it doesn't matter which one, but there has to be a single argument which is strictly decreasing. And if there is no single argument, but it's somehow a combination of multiple things, you have to explain it, I think. So Oleg says that the as pattern doesn't work because the recursive call is at a different type, and that requires learning things about x and xs and using cons at a different type. Yeah, that is probably true. So this cons, if you look at it in the refinement type sense, is used at a different type with additional knowledge compared to this one. And that's probably why the as pattern doesn't work. Yeah, I think that is. Okay, so that's merge. Let's see that we at least managed to ideally finish this. So then we still have to write split. So for split, there are multiple options. I mean, you can sort of go back and forth, but actually let's perhaps look at how we want to write merge sort in the end. So let's look at this one already. So the idea for merge sort in the end is that if we call merge sort on an empty list, we'll return the empty list. If we call merge sort on a one-element list, we'll return the one-element list. And if we call merge sort on an at least two-element list, I don't actually have to pattern match in that case, then we're going to split. Then we're going to say case or let, doesn't really matter very much, xs or ys zs. Right, and then we're going to merge m sort of ys and m sort of zs. So that is the idea. Now, split. I mean, there are multiple things to note here. I mean, first of all, of course, we want the liquid Haskell type in the end to go from a list of A to a sorted list prime of A. Okay. So there are a couple of things to note here. So we know in this case where we call split that that the input list has at least two elements. So we can use that. Right? So we can use that in split. We can write split in such a way that it can assume that it is working on a list of at least two elements. And again, for termination, we have to say something about these recursive calls being on shorter lists. But if we write split in a sane way, so that it performs an actual and not a degenerate split, right? So that it doesn't split so that one list is empty and the other list is the complete list, but that both lists have at least length 1, let's say. Then we also know that essentially both recursive calls become shorter, right? But we need to like establish this somehow in split. And we need to make sure that that split establishes this. And in fact, I mean, I'm not quite sure at the moment how the split at is predefined. I mean, like how good the type of split at in the base libraries is. Let's actually have a look. So if we would call split at on just in line here on length access divided by 2, and it actually goes through. Okay, so this is easier than I was afraid of. So we don't actually have to establish anything here, but it does rely on this. So if we wanted to write split as a separate function, that is perhaps still enlightening to try to write split as a separate function on a list of A that produces a pair of 2 lists of A, where split is defined to be just split at of length access divided by 2, just in the way at which type we're really using split at here, right? What we are trying to establish and what we're using. So the assumption here is that the input list is a list of length at least 2. That is something that we know in the case up there. And then that we get, as a result, a pair of 2 lists for which we know that, I mean, let's actually write it using, let's just write a pair, a result, which is a pair of 2 lists. And let's write it using first and second, because I mean, it's a sort of a symmetric property. One could also try to like reason about the components individually, but let me write it like this. So we would like to see that the length of that the length of first R and the length of second of R is the same as the length of access. And we would like to see, this is this non-trivial split, that the length of the first of R is greater than 0, and the length of the second of R is greater than 0. We need all these things. And now something is wrong. Illegal sort error. Let's see. This is probably a syntax thing again, or perhaps I've actually made something wrong. Let's just put some parentheses there. No, unfortunately not. Anybody sees this? Oh, here. This is wrong. I see. Okay, I was looking in the totally wrong place all the time. Thank you, Jens. Okay, so that seems to be accepted, but now the definition is not okay. So perhaps I've actually made a mistake somewhere in the specification after all. So let's have a look. Or perhaps the type of split that is actually not strong enough, but because we are, but it should be. I think it should be. Length of first of R and length of second. Yeah, the type errors. I mean, you can. I mean, I have in some situations, but not in a situation where I'm already presenting and I'm less relaxed than normally. I think the type errors are not particularly useful. But if you really need to, and if you're stuck with this for a long time, I mean, it's a good point. You can still go and look at all these things that are presented to you and try to basically, that's what I do then sometimes. I basically almost write them down or copy them into a text editor at least, and try to do some manual simplification and try to reproduce this reasoning. So it is certainly better than not getting anything, and there is helpful information contained in this, but it is very far away from my perspective from just glancing at it and immediately seeing what's wrong, unfortunately. Not sure whether it is in any way easy to present it in a much better way, though. I mean, sometimes redundant information could perhaps be identified more easily, but in many cases, I just think it's relatively difficult. Yeah, what Gabor suggests to basically to split like in a sort of interleaving fashion. That would also be okay. I mean, I could see whether that one goes through with the given type signature. And so Gabor is suggesting this specifically. Do a recursive call here on split. And that one works. Oh no, it doesn't. Why not? Oh yeah, no, that one does not work with the given type. So now we either, yeah, no, okay, so that's the reason there essentially. So then we need to have a base case, and then we need to relax this, and then we need to strengthen this. So I mean, so basically we can no longer assume that the length is greater than or equal to, right?
Also, it is still not total, right? You need the
yeah, no, we then would need to say something explicitly for these cases, right?
Yeah.
And then of course, now these are not type correct with respect to the given type. So then we have to say something like this always holds, and this only holds if the length of access is greater than or equal to 2. Then that implies, I think that can be written just like this. And perhaps I need another pair of parentheses around this, and then this, and then this. That's quite miraculous, but it seems this is accepted. Okay, I'll accept that. So that's fine. I'll go with Gabor's definition then, which is also okay. I mean, it just splits in a different way, and this type should still be fine because we have this, and then actually we should be able to use case split access of rather than the other one here. And that also still type checks. Thank you. There is a but length second r greater 0 is not unconditionally true. It is true under this precondition that length access is greater than or equal to 2, right? Yeah. So that's exactly why I had to modify the result type, and it is relatively difficult to read. So let me see if I can split it, but yeah, perhaps a little bit easier. Something like this. Right. So now that the sum is the length of the original list. The sum of the components is the length of the original list. Does unconditionally hold, but that the length of the two component lists is strictly greater than 0 is conditional on the input list being greater than or equal to 2. But that is the case that we're calling it in here, and that is the case that we need here together with this notion here to reason that both the length of ys is smaller than the length of xs and the length of zs is smaller than the length of xs, and that's why we can still like write this function and get it through the termination checker without an explicit termination measure, because that is established now. Okay. I think that is probably a point where it does not really make sense to start anything completely new anymore, but it does certainly make sense to perhaps still discuss a number of variations or questions, perhaps also more general questions. So perhaps to summarize, I mean, I hope I have been giving you well, a little bit of an introduction of what kind of things you can be doing, what kind of reasoning you have to be doing, how the type language of Liquid Haskell looks, that you can like do stuff with your own data type and annotate them, that you can refine existing types in various different ways. What I haven't really been showing is something that is very powerful, is measures, so-called measures. That is, there are actually two notions of measures, and both are interesting, but they are completely independent, more or less. So one notion, the one that I was just referring to, is that if you have a new data type yourself, you can define functions over it that have a particularly simple form, that are essentially just catamorphisms on the data type, basically that follow the standard recursive pattern, one case per constructor at the top level, and just recursive calls on the immediate subcomponents. If you have such a function, you can declare it to be a measure of the data type. And what then happens is that Liquid Haskell will retroactively refine the post conditions of all the constructors of the data type with the information obtained from the measure. So how can you think about this? Perhaps the simplest example, without having to write very much, is if you think of a tree type, right? And I'm defining a function that computes, say, the height of the tree. Okay, the height of the tree can be trivially inductively defined by saying the height of a leaf is 0, and the height of a node between two subtrees is 1 plus the maximum height of the two subtrees. So that is a typical standard definition. Now, if you declare something like this, like a measure for the tree type, then subsequently Liquid Haskell will always, when you're in a leaf case, know that the height of that tree is 0. And always when you're in a node case, know that the height of that node is 1 plus the maximum of the node of the subtrees. So whenever, in every situation where you're using the constructors, you have this additional information available. And the nice thing is that it's a little bit related, perhaps, or feels a little bit related to algebraic ornaments, if you've ever seen something about them. So the interesting thing about this is that you can write these kinds of functions separately from the data type, right? And you can declare them to be measures later on, and they refine the existing constructor types. But because they're only refining the post condition, so they're establishing additional knowledge, they're not going to break existing programs. So there's just additional knowledge that becomes available that you can then use in an entirely modular fashion. So that is really, really nice. And the other notion of measure is you can declare uninterpreted functions. So you can essentially say to Liquid Haskell, I want a function that goes from integers to integers, or I want a function that goes from integers to Booleans. But I'm not going to say how it is defined. And the only way you're using it is in assumptions. Essentially, you're assuming certain things about the function by giving refinement types for certain other functions. And that way you can, for example, introduce a predicate, like going back to this idea of checking email addresses. You could introduce a sort of a predicate valid email that is a function from string to bool, something like that. You could introduce this as an uninterpreted function, and then you could like use it in refinements, right? And just establish how it behaves by these refinements, by saying like, this is a function that produces a string that where valid email is true, or where valid email is true exactly under these and these conditions. And then the only thing that tree or Liquid Haskell will know about these functions is the thing that follows from the assumptions that you've been made, and you can treat it otherwise as a completely abstract thing. That is quite useful for defining your own interfaces for existing libraries and being able to do good stuff with it. Okay.
There are a few questions on tooling. Let's begin at the top. By Artem. The question is there a plan to make these Liquid Haskell synonyms like sorted list prime entities that GHC IDE knows about, so it can provide stuff like auto-completion?
Yeah, so it's very much my goal. I'm not sure how much time I will personally have to go about this. I mean, so for this work that WellType has been doing on the plugin, we have been funded, but like doing additional IDE improvements will most likely just be depending on contributors. But yeah, I mean, my intent is to improve the IDE tooling for Liquid Haskell a bit more. And as I said initially, there is already this old plugin that Alan Zimmerman has written for Haskell IDE engine. I don't know whether it had this auto-completion, but it had at least a sort of inference for subterms. But both are interesting features, and it would be interesting to add them to Haskell language server, which is based on GHC IDE. So it's certainly worthwhile trying to, but it may rely on contributors like you to help out, because I'm not sure whether it will really happen just on its own.
So another question: when there were Liquid Haskell type errors, you basically just ignored them, didn't try to understand them, but just looked at your code again and tried to find the error. And
I think I think I did comment on that one. I think I did discuss this one already.
Okay, then. So if you want to find out the type of a function or an expression in GHC and you're using GHCI, so you're using the REPL, usually you use the command :t. Is there some equivalent for Liquid Haskell?
Yeah, that is a very, very good question, and that is the single most annoying thing when working with Liquid Haskell that I have. That, I mean, this is essentially this sort of like, why can't I do quick type inference, and why can't I get at the types of sub expressions, or why can I not look up these things? So this is again, but it's going into the direction of IDE support. I don't think you can do full inference of arbitrary terms, because Liquid Haskell is not really, I mean, it's mostly working with checking, right? I mean, so if you're really writing :t with an expression rather than just a name, that's not necessarily going to work. But what you would want to work is this stuff that you also get for the IDE, that you can highlight a sub-expression in an already existing program and get its Liquid Haskell type. And Liquid Haskell does compute all of these and does have them available. It's just a question of making them available. And the other thing for the GHCI interface for existing definitions, right? Looking up just the stored Liquid Haskell type for an existing definition would be very nice to have a command for that. I agree, but at the moment, I don't think it exists. Next, what is the next?
Next question is about Liquid Haskell and theorem proofers. What do you think would be use cases? When should you choose to use Liquid Haskell? When would a theorem proofer like Coq be a better choice?
So I mean, like Coq in particular, I mean, even with this like HS to Coq work and so on, which is currently existing, I mean, the problem is very much that you have to go to a different language, right? And then you have to learn that different language as well, which is by no means trivial. And Coq is very powerful, and I like to prove things with it, and it's fun, but it is a lot of effort. right? I think the barrier to entry is really, really high. If you have something that you already know, you want to like reason something about, then yeah, you can do it, and you can invest a lot on, and ultimately you will be able to have something that is really, really trustworthy, because like the COG developers are trying relatively hard to make proofs that are being done in that system actually reliable. With Liquid Haskell, I think the focus is very different. The idea is that the way it's set together, I don't think the trust is extremely high you can get if you're proving something. I mean, ideally, of course, it's all good, but I mean, there may be bugs and there are all sorts of strange corners. But at the same time, the barrier to entry should be much lower, and it should be much lower to do something to little parts of your system and directly to your system, right? Because you're having a Haskell program underneath, and you're annotating your actual Haskell code. You're not doing some separate development. And if you're making changes to your Haskell code, then you immediately your types stop working. So so I think that is actually something that I find very attractive about Liquid Haskell compared to many other options, that it is this sort of optional add-on that gives you quite a lot, that compared to going full dependent types within Haskell is often actually easier. You have to do less work for a lot of different things that are going into that direction. You're going to have less overhead on the Haskell side. You perhaps also have to have less overhead actually performance-wise on your Haskell side, because very often you can just annotate your existing Haskell code with better types rather than going to GADTs and other stuff which may have a runtime overhead as well. So I think that's sort of the direction which I find attractive for Liquid Haskell. But of course it is by no means ideal either. Many things are very difficult. The syntax is strange. It is a sort of a historically grown system which has a lot of cool features actually, but many of them are actually quite well hidden, and you have to really dig very hard to find out how certain things even work. So documentation could be a lot better. That's all there, right? And then the reliability of the proofs is doubtful ultimately. I mean, gives more trust, I would say, much more trust perhaps even, but is not good enough to actually say like I have definitely proven this. Let's see, more questions by Artem. In the beginning, you said quite certain that Liquid Haskell will not become a proper part of GHC. Why would that not be possible someday? Well, someday, right? That's fine. F star seemed to be okay with the dependence on SMT. Well, okay, so first of all, as F star, I'm not an expert on F star, but as far as I know, F star has been more or less designed right? I mean, to be a language that has this kind of dependence. I mean, I don't think it would be impossible someday, right? To move it completely into GHC, but just looking at the realities, I think it is very, very, very far off at the moment. And I mean, GHC is this huge language which has all sorts of things going on, and Liquid Haskell basically has cross-cutting concerns with almost all of these features to some extent. And Liquid Haskell is, I think, rather amazing in the amount of Haskell features that are supported by Liquid Haskell, mostly operating via core code. So the stuff that is sent to the SMT solver is based on the core code. And by doing that, a lot of strange surface language features that are really, really recent language extensions are nevertheless somehow supported in the context of Liquid Haskell. But saying this is a first-class GHC feature and has to be maintained with GHC and has to somehow be held to the same standard is at the moment, I think, not going to happen. I just don't see. I neither see that there is enough money or funding available to turn Liquid Haskell into the tool of the robustness and quality that it would probably have to have. Not yet. I mean, it would be good if it would happen, but also for the maintainers of GHC. I mean, this is already like very difficult to maintain GHC, and taking on this huge extra thing is I think asking too much. And actually the plugin system is exactly created, I think, for this sort of purpose, to make it easier to maintain these things next to GHC. And if anything, I would argue one should try to improve the plugin system further so that the integration can become tighter and that it doesn't feel like it is a second-class thing as much anymore as it currently is. I mean, certainly do such things as being able to write a Liquid Haskell type signature directly, right, as part of your Haskell code and omitting the Haskell signature. That would already go a long way. And that is very much in reach, I think, or having a GHCI integration that you can use :I on something and get a Liquid Haskell type as well. All these kinds of things, I think that is possible by improving the way plugins are handled. But doing full integration, I don't see happening anytime soon. But it's possible, I guess. I mean, I shouldn't have said never. It could happen. Where can I find the stronger fold R definition? It is in the, I mean, like I think probably the best answer to give is there is a real wealth of interesting examples in the test suite of Liquid Haskell. So so there are loads of test cases, both smaller and larger ones, in the Liquid Haskell repository. And just reading through them is very enlightening to see lots of interesting use cases. And you can also find the stronger fold R definition in there. But for this specific case, I can actually just try to commit it to this repository afterwards so that it is in this one as well. I'll put a file called induction.hs in there, which has this. Then there is a remark about that in the directory.liquid, you get an HTML output. I actually wasn't aware that this is always automatically generated. I thought you had to pass an additional flag, but it's possible that it always is. And indeed, Liquid Haskell can, just as it can produce this JSON output with additional information, it can also produce some sort of HTML output where you have some annotated version of your source code. So that's a good remark. Then there is a question, how viable would an Isabelle sledgehammer style tool be that throws in all proofs and tries brute force solving for 30 seconds? So I don't know. I mean, it's possible that it would work. I mean, but I think the way this usually works, this sort of stuff usually works, and I think it probably works for Isabelle as well. Although I'm not the Isabelle expert, but like all these automatic tactics work for Coq as well. That ultimately there is some witness of your success, right? And doing brute force solving with a timeout is very dangerous. So you have a type checking program one day and you don't have a type checking program the next day. And with Liquid Haskell, there is no witness. I mean, there's no proof term being generated or whatever. So even if it was possible, I'm not sure whether it's a system I would find practical to work with. And then there is a question, follow-up question about Coq. Could it be possible to read user-supplied external proof scripts, spit out the theorems you'd need to prove in those at some point for theorems that are hard to prove automatically? How hard is it? Oh, so whether you could, okay, I think the question is whether you could sort of generate Coq proofs from your Haskell program. And I think that this goes very much into the direction. I mean, if you haven't seen it, there is this work by, I'm sorry, I know that Joachim Breitner worked on this and lots of other authors, but I can't produce the complete list, even though they certainly all deserve credit. But I think it's called HS to Coq. And basically the idea is to go from Haskell code automatically to Coq proofs. And I guess your question would essentially amount to, like, could one somehow combine Liquid Haskell with that, so that there is a way to, like, sort of like, if something can be proven within Liquid Haskell, then already trust it and sort of like only try to move to cock the rest of the stuff. I don't know. Avenue for future research, perhaps. It's conceivable. I think we should probably stop, because there is another round of talks in 20 minutes. And I'm around all weekend, so I mean, I can still answer further questions in textual form on the channel, or also in the break rooms sooner or later. But,
yes, I agree. But first, I have asked all of you to unmute, so we can thank Andres for the interesting workshop.
It was a pleasure. Thank you very much. Bye.